Okay, for part D, we are to determine the particle's instantaneous velocity still at 1 second. But this time, we are asked to use the derivative of this position as a function of time. And then we are to compare our answer with the answer that we got in part C. So this was the slope of the tangent line. This one, let me show you. The slope of this tangent line, we calculated it as negative 2.2 meters per second. So, I hope you know how to get the derivative of this polynomial, no? We just use the power rule. So, by definition, let's move this here a bit. By definition, we know that velocity instantaneous, so v at any time value, v as a function of time, we just get the time derivative of our x as a function of time. Okay? So we simply substitute, we get the time derivative or the first derivative of this. So x as a function of time, that would be this expression. Then we get the time derivative of that. So d over dt, this is what we call a mathematical operator. We call time derivative. Okay? So meaning, we just substitute here the expression for x of t. Howd na mo ani, no? Okay, you have this in your senior high school. So that would just be t squared minus 4t plus 2. Okay? So we now get the time derivative of that. It's just power rule. So this becomes exponent here times this variable, and then magma-minus 1 tayo sa exponent. So it becomes 2t, and then remember this is 2 minus 1. And then this one, we have invisible 1 exponent here. So it's just like 4 times 1. And then you have t1 minus 1. And then 2, since derivative means change and your 2 here is a constant. Kaya nga siya tinawag na constant kasi hindi siya nagbabago. So as time goes by, this value here does not change. Therefore, its time derivative of this constant is 0. Kaya walang derivative ang constant because derivative means change. So, we now say that our general expression for v at any time value is just 2t, okay, minus 4. And then the unit of this should be meter per second. So please take note that this t here can have any value. So this is our general equation for v at any time t. Since we are to determine velocity at a particular time, so itong general equation natin for v as a function of time will just be, so instantaneous velocity, time value is 1 second, and then we just substitute. So this becomes 2 times 1 second minus 4. Then we have negative 2 meters per second. So this is now our velocity instantaneous when time is 1 using the derivative of x as a function of time. And by inspection, 2.2, there's just a difference of 0.2, no? So we say therefore that the way we estimated our tangent line here is good enough because the slope that we got is really close to the calculated value. So since we have this x as a function of time, when you get the derivative of that, you'll get a more accurate value of your instantaneous velocity. Okay? So this time, hindi ganun kalaki ang difference ng mga answers natin. No? Exact talaga na pareho tayo kung tama yung pagkuha mo ng derivative. Okay? Pero dito, when you get the slope of this tangent line of your x as a function of time, medyo may konting difference tayo dito from one another. Okay? So, if the question here were determine the particle's velocity at, let's say, 3 seconds, then you still need to establish your general equation first, saka ka magsasubstitute ng any time values na gusto mo. So, it tells us here that science, or particularly physics, it has the predicting ability, no? So, once you have this, makakapredict ka na, okay, after ilang seconds, ganito na siya kabilis at doon siya papunta. So, that's the power of science. We are able to predict because alam natin how each physical quantity relate with one another. So, that's how we study and understand the physical world. Because the physical world, the whole universe, it speaks through mathematics. Okay? So, I hope you will master your mathematical skills, yung mga theorems in algebra, trigonometry, in your calculus, kasi yan silang gagamitin natin to understand our physical world. Okay? So, we are down to the last part of this example in the next video, and that would be to determine the particle's acceleration. Okay?